Hello everyone, my name is Rajesh Lingala. Today's problem statement is to design a low-level design for chess game using OOPS principles such as abstraction, inheritance, encapsulation, and etc. For that, the scope of this chess game is player management, chessboard representation, and piece movement, and game state management and move validation. This video is divided into three sections. The first section is about the class diagrams of the chess game and means what the classes we have been used in the building the chess game. And in section 2, we are going to see the codes for the classes which we have been built. And section 3, how the chess game is going to implement it in the console in both static and dynamical way. Section 1 is going to explain by myself only, and section 2 is going to explain by Bhavya, and section 3 is going to explain by the Fanindra. Okay, we are going to start our first section, the UML diagram. Firstly, we need to find what classes we have to be created in the building the low-level design. Firstly, we will take this pieces. What pieces we need there in the chess game? It may we have a king, queen, bishop, knight, rock. These all are pieces which are be presented in the chess game. If you take the king, it has in a starting position and ending position. If you take a king, it can move only the one cell. It may be in front of or side. In any direction, it can be moved, but it takes only one movement. If you take the it can move in all directions and it can take direct to the starting to ending. This all comes under the pieces. Pieces has an abstract method which has an to class from class which returns the true value also. And come to the moves. If you take an bishop, bishop can move in the horizontal, but in this direction only. It cannot go in this direction. For that, we need to implement our logic how the movement will be takes place. If we taken 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. If you take this piece, right now it is in the 0th and first position. If it want to go to 3, 1, it cannot be possible because the movement cannot be possible going to the upwards because it can only move to the this direction only. It means we can move only the 6 1 2, maybe 4 um, 4 3, like that only we can move. We can't move in this all the directions. How like that every piece and its own properties. In this we can see it can takes the inheritance properties because this all has the same type of properties such as from position to from cell to which cell which we want to move. One while come to the cell position. Cell position is nothing but if you take this puzzle, this piece, it has an cell position, right? It can go to the direction. It has taken 2 steps forward initially, but after getting here, it can go to only one position, or else if this black is present here, it can take it can kill this direction. It can kill only cross direction only. It cannot kill straight or horizontal direction. If you take this horse can go in this L direction only. Like that every puzzle has its own properties. Once we come to colors, we can see it has only two colors which may be white or black, and every cell has an color alternate color. If it has white, it has black, white, black, like that every cell having the alternate colors compared like that. And come to the account player, we can see it has only the two players. It may come one is black player and another one is white player. Chessboard, we can see this all takes place in the chessboard only. It has it is an 8 by 8 matrix, 8 by 8 chessboard. Means we can see 64 cells. Every cell has its own address. For example, it has a 4 by 2 cell. We can use this as an double list, means a list is taken, means it has an a list like this present here. The game is with these simple classes. We can form the chess game in the low level design. Next part will be continued by my friend.
Now, I am going to continue the explanation of the codes of our design. The goal of this design is to model a chess game system using object oriented principles in Java. The system is well structured, flexible, and modular, adhering to the solid principles and focusing on the separation of concerns. Let me walk you through the key components and the thought process behind the design. The core components of our design are: the chess class acts as a central controller, managing the game flow, players, moves, and the game board. It keeps track of the current player, the game position, the game status, validates the moves using methods like a player move, and end game, etc. And the chessboard class consists of a 8 into 8 grid of cell objects. Each cell holds a position. In the cell class, each cell holds a piece and specific position, the cell position. The design uses a two-dimensional array of cell objects to represent the board, ensuring a clear mapping of pieces to their locations. Responsibility for placing and moving pieces is encapsulated in the chessboard, enhancing the modularity. The piece class, which is an abstract class, from which the many subclasses are implemented, like bishop, knight, pawn, queen, rook. All these pieces are the subclasses of the abstract class piece. Defining a contract for movement validation using the validate method that each specific piece subclass implements. Example: the rook. um, for example, the rook which moves in a straight line, and the bishop which moves diagonally, and the knight which moves in a L shape. The hierarchy promotes the polymorphism and allows easy extension for new piece types. Player class is associated with an that stores the account class that stores the user information like username, password, name, and contact information such as email, phone, etc. Players are assigned colors black or white and taking turns making moves. It is done by using the enum color, where the player assigned with a color either black or white, and the game status, which is an enum that defines the states like active, paused, or win, etc., ensuring the system can handle different phases of the game. And the move class tracks every action, including the piece moved and starting and ending positions and any captured pieces. This ensures moves can be reviewed or reversed if needed, aligning with the potential features like undo functionality. The main design considerations of this design are the um, modularity, that each class has a single responsibility. For example, the chessboard manages the board state, and where the player handles the player specific data. The modularity makes the code easy to maintain and extend. A scalability, the use of an abstract piece class ensures the adding new piece types or modifying the rules is simple and doesn't require changes to existing code. Like these all pieces having the same code without changing, but only changing the rules specific to that piece. And like encapsulation, the key data like the board state and the player information are kept private with the control access through the getters and setters, ensuring the integrity and reducing the bugs. Polymorphism, the moment rules for each chess piece are handled via method overriding in subclasses of piece, promoting the reusability and code clarity. Like all these having the same methods are handled via the method overriding. And the game status and the move classes are designed to support the feature game status and move classes are designed to support the features like AI opponents, timed games, and game saving functionality, etc. Mainly, this low level design is a great example of clean object oriented programming. It balances the functionality and readability while staying future proof. By focusing on the modularity, extensibility, and adherence to the solid principles, the system ensures that the chess game is not just playable but also easy to maintain, expand, and enhance. Thank you.
Hello everyone, my name is Parmendra. I'm going to explain about low-level design of the chessboard game. We have implemented this chessboard game dynamically and statically. In static, we have written the code main.java. In that main.java, we are defining these cell positions like static, like cell positions, terminal positions are static, and the two positions are statically. In dynamic, we are taking the dynamic input from the user. Apart from that main.java, we have another classes like account.java and bishop.java, cell.java like this. We are explain one by one. In account.java, if you see, we have the account details of the user, like username, password, name, and email. Along with that, we have phone. We store these values in the user. Since we are playing this chessboard game, we have multiple users. We are storing their details of these. And coming to bishop.java, since we have bishop for two players like y, so it has two colors. So we need to initialize with color, which color the bishop is. And we have a valid function which validates whether the movement is valid or not. Since it is a bishop, we need to know horizontally. This is the bishop. This is a bishop. We need to know horizontally. If we have entered the cell positions like this, like 0 comma 5 to 0 comma 5 to 0 3 comma 5, then it is a invalid move. Since it is not diagonal to bishop and it is not correct. And coming to cell.java, we have generally think what the cell consists of is is it is it consists piece or may not be, and it must consist cell positions like row and column. This is a cell position 0 comma 5. And coming to next cell position kinds of column values. Chessboard. Chessboard is an 8 by 8 matrix in which we have multiple pieces like rook, bishop, knight, king, queen, pawns, etc. for both black and white. We are initializing these chessboard. Along with that, we are initializing the pieces. Here we are initializing the pawn for first row and sixth row. This sixth row and first row. This sixth row and first row we are initializing the pawns, and we are initializing all remaining pieces. In next, color.java consists black and white, since the just consists black and white. And coming to main.java, as I mentioned, we have two players, which username, password, name, email, and color. And we are creating an object for chessboard. And we are starting the game by using from and to positions by iterating these from and to positions for alternative players. After the end, we are after the end, after the end, we are Getting game is over, starting also complete. Just execute this. See, showing that Rajesh versus Kani, Rajasthan, Kanistan, Rajasthan, after iterating with all the given six positions, it's saying game is over, starting also complete. Now, see the dynamic calls. I did not explain the pawn or Java, queen, rook, since it is similar to bishop. And coming to main or Java, in main or Java, since it is dynamic, it asking about the player one name, to say, initializing the chessboard object, and saying current player player one. After that, we are taking the from and two positions from the player, current player. First, player one will enter these values. After that, we are checking whether in that we are getting the piece value from that from position, and we are checking whether there is piece or not. If there is a piece, and we are checking that current player piece, this current player's piece or not. After that, we are validating. If all these conditions are success, then the board will update the piece from position to position. After that, we are saying that swing is successfully. If the current player is player one, then the next player is player two. If the current player is player two, the next player in the next move is for player from player one. If any of the above conditions are failed, it will show the invalid. No, execute this also. So, yeah, I'm going to do that. Task me, I'm entering the Rajesh. Fine. I'm entering 1 comma 2, like 1 comma first to second one to second to seven. Since it is a valid move, it is this to this entering correct. If I now I am entering wrong move for blacks, like 6 comma sorry 6 comma 1 to 7 comma 2 sorry 5 comma 2. It is invalid move because horizontal movement sorry diagonal movement of pawn is invalid. In this way, this code is working. This low level design is working. Thank you. Thank you for watching this. Thank you.